Welcome to a new episode of Astronomy Daily. I'm Anna, and today we're diving into some truly fascinating developments from across the cosmos. We have a packed show exploring everything from relics of the space race to cutting-edge astronomical research. Coming up, we'll update you on a story I brought you last week as we track a Soviet Venus probe making its return to Earth after more than 50 years in orbit. Then, we'll examine China's bold plan to sample Venus's toxic atmosphere. We'll also explore how the upcoming Roman Space Telescope will hunt for mysterious rogue planets wandering through our galaxy without a star to call home. Plus, we'll hear about an ingenious satellite rescue mission using gravity as a slingshot. And finally, look at new data that might challenge Einstein's theories about dark energy. It's an exciting day in space science, so let's get started. To kick things off, let's get an update. In the early 1970s, as the space race between the United States and Soviet Union was in full swing, the Soviets launched an ambitious mission to explore our nearest planetary neighbor. The Cosmos 482 probe was designed to land on the inhospitable surface of Venus, protected by a 3.3-foot wide titanium shell lined with thermal insulation. Launched in 1972, the mission unfortunately never reached its Venusian destination. A rocket anomaly during launch left the spacecraft stranded in an elliptical orbit around Earth, where it has remained for over 5 decades, silently circling our planet as a relic of early space exploration. That lengthy orbital journey appears to be coming to an end. The 1,190-pound spacecraft is expected to re-enter Earth's atmosphere shortly, with new predictions suggesting it would return around 1:54 a.m. Eastern Time on May 10th, though with a substantial margin of error of plus or minus 9 hours. Due to its orbital path, scientists calculated that the craft could re-enter anywhere between 52 degrees north and 52 degrees south latitude, a zone covering most of Earth's surface. This created some uncertainty about exactly when and where the probe might return. However, experts stressed there was little cause for concern. Unlike other space debris that often breaks into multiple pieces, Cosmos 482 was expected to remain largely intact during re-entry, presenting a lower risk profile. As the Aerospace Corporation noted, while the risk is non-zero, any one individual on Earth is far likelier to be struck by lightning than to be injured by Cosmos 482. Astronomers and satellite trackers have been monitoring the probe for years. Astrophotographer Ralph van den Berg of the Netherlands has captured images of the craft for over a decade, recently photographing what some speculated might be a deployed parachute, though other experts attributed this to optical distortion. Cosmos 482 represents an important chapter in Venus exploration history. It was part of the Soviet Union's groundbreaking Venera program, which achieved remarkable firsts, including landing the first probe on Venus's surface in 1970 with Venera 7, and later capturing the first color images from the planet's surface with Venera 13 in 1982. As this Cold War artifact makes its final journey, it serves as a testament to the ambitious early days of planetary exploration and the technological challenges involved in venturing to our most extreme neighboring world. While on the subject of Venus, China has set its sights on one of the most hostile environments in our solar system with an ambitious new plan to collect samples from Venus's toxic atmosphere and return them to Earth. This joint initiative involves several major Chinese space organizations, including the Chinese Academy of Sciences, the China National Space Administration, and the China Manned Space Engineering Office. The mission is tentatively scheduled for launch somewhere between 2028 and 2035, though specific details about the methodology remain limited. What we do know is that the mission faces extraordinary challenges due to Venus's extreme environment, a planet where surface temperatures reach nearly 900 degrees Fahrenheit. Atmospheric pressure is 90 times that of Earth, and the air consists primarily of carbon dioxide with clouds of sulfuric acid. Despite these hostile conditions, Venus continues to intrigue scientists, particularly after recent research suggested that microbial life could potentially exist there in some form. This Chinese mission aims to help settle that debate by bringing actual atmospheric samples back to Earth for detailed analysis. The mission will also investigate one of Venus's most puzzling features, how its clouds apparently absorb ultraviolet radiation when, according to our understanding of physics, they shouldn't be able to. This mysterious phenomenon has generated several scientific hypotheses that this mission could help confirm or rule out. Based on preliminary information, the ambitious undertaking will likely require at least two spacecraft working in tandem. One vessel would remain in orbit around Venus, while another would brave the planet's intensely stormy conditions, descending into the atmosphere to collect gases and particles before returning the samples to the orbiter. A similar concept was previously proposed by researchers at the Massachusetts Institute of Technology in 2022, though NASA ultimately didn't select it for development. That design featured a Teflon-coated, corrosion-resistant balloon that would carry a collection canister through Venus's clouds before sending the samples back to orbit and eventually Earth. The value of returning physical samples to Earth cannot be overstated. Laboratory facilities here would allow for far more sophisticated and comprehensive analysis than any spacecraft could perform on its own at Venus. However, the technical challenges of accomplishing this across tens of millions of kilometers presents extraordinary engineering hurdles. While several Russian probes did successfully land on Venus's surface in previous decades, they only survived for a couple of hours before succumbing to the extreme conditions, and none attempted a return journey. If China's mission succeeds, even with just a small sample of Venus's atmosphere, it would transform our understanding of Earth's nearest planetary neighbor and potentially provide insights into the evolution of our own world's climate and atmosphere. Next up, have you ever wondered about planets that don't orbit stars? Astronomers call these wandering worlds rogue planets, and they might be more common in our galaxy than we ever imagined. The upcoming Nancy Grace Roman Space Telescope is poised to revolutionize our understanding of these mysterious cosmic nomads. Over the past decade, scientists have speculated extensively about rogue planets in the Milky Way. These free-floating worlds don't have a home star providing them warmth and light. Instead, they roam through the vastness of interstellar space, ejected from their original star systems. With current technology, they're incredibly difficult to detect precisely because they don't shine or reflect light like planets orbiting stars. Astronomers estimate the Milky Way could contain millions or possibly billions of these planetary wanderers. If those numbers prove accurate, there could be more rogue planets in our galaxy than there are planets orbiting stars, a truly mind-boggling possibility. Without the warming influence of a star, these worlds are likely frozen, icy, and seemingly inhospitable. The Roman Space Telescope will employ a specialized search called the Galactic Bulge Time Domain Survey to detect these elusive objects. Scientists expect this survey will help them find anywhere from several hundred to several thousand free-floating planets, providing an unprecedented census of these mysterious worlds. Roman will use both the transit method and microlensing to spot these rogues. The transit method detects the dimming of light when one object passes in front of another. Microlensing, meanwhile, observes how gravity from a foreground object warps the light from a background star, creating a distinctive pattern that can reveal even non-luminous objects like rogue planets. What's particularly exciting is that Roman might help answer fundamental questions about how these planets form and get ejected from their original systems. The dynamics of early planetary systems are chaotic, with gravitational forces sometimes flinging newly formed planets out into interstellar space. By analyzing the mass distribution of rogue planets, scientists can better understand these formative processes. The telescope will be especially valuable for detecting smaller rogue planets, worlds less massive than Earth that have previously escaped our notice. These smaller planets would theoretically require less energy to eject from their star systems than their larger counterparts, potentially making them the most common type of rogue planet. Though the Roman telescope is still a couple of years from launch, astronomers are already anticipating the transformative impact its observations will have. Beyond rogue planets, it might even detect other non-luminous objects wandering through our galaxy, potentially including primordial black holes. When it comes to understanding the full population and characteristics of objects in our galaxy, the Nancy Grace Roman Space Telescope promises to fill in crucial gaps in our knowledge, helping complete the cosmic census of our galactic neighborhood like never before. Next today, more Chinese space news. In what can only be described as an impressive display of cosmic problem-solving, China's Technology and Engineering Center for Space Utilization recently pulled off a remarkable rescue mission in space, saving a pair of wayward lunar satellites through an ingenious gravity slingshot technique. Back in March 2024, China launched two satellites named DRO-A and DRO-B aboard a long March 2C rocket. These satellites were destined for what's called a distant retrograde orbit around the moon. That's what the DRO in their name stands for. Their mission was to provide navigation and tracking for spacecraft operating in Earth-Moon space, essentially serving as celestial lighthouses. While the rocket's first and second stages performed flawlessly, a technical issue with the Yuanzheng-1's upper stage prevented the satellites from reaching their intended orbit. To make matters worse, Mission Control temporarily lost contact with the duo entirely. When the team finally located the satellites, they discovered the pair were spinning in an orbit much closer to Earth than planned. This could have spelled disaster for the mission, with years of work and significant investment potentially wasted. As Zhang Hao, a member of the rescue team, explained, it would also be a mental blow to the team. The challenge was particularly complex because the satellites had sustained partial damage during the launch, limiting their ability to capture enough sunlight to power the necessary course correction. This is where the team's creativity truly shined. Rather than attempting to force the satellites into position using their limited power resources, engineers devised a plan to use the natural gravitational forces of the Earth, Moon, and Sun to gradually slingshot the satellites toward their destination. This gravity assist technique essentially borrowed energy from these celestial bodies rather than relying on the satellite's own limited fuel reserves. As CSU researcher Mao Xinyuan put it, if you don't want to consume much energy, you must replace it with something else. We chose to consume more time in order to save energy. The patience paid off, though the rescue operation took a substantial 123 days to complete. By mid-July 2024, both satellites had successfully reached their intended orbits around the moon. And about 6 weeks later, DRO-A and DRO-B separated from each other as planned. They're now working alongside a third satellite, DAR-OL, which had previously launched to low Earth orbit. Together, these satellites form a navigation network that can dramatically reduce the time needed to locate spacecraft in Earth-Moon space. According to Mao, they can now pinpoint a spacecraft's position in just 3 hours, compared to the 2 days or more required by traditional land-based positioning systems. This remarkable save demonstrates not only China's growing expertise in space operations, but also the ingenuity that makes space exploration possible, even when things don't go according to plan. And wrapping things up today. Some of the most fundamental aspects of our universe may be up for reconsideration, as recent findings from the Dark Energy Spectroscopic Instrument, or DESI, suggest that dark energy, the mysterious force thought to be driving the accelerated expansion of our cosmos, might not be constant after all. This potential discovery challenges one of modern physics' cornerstone ideas, Einstein's cosmological constant. For those unfamiliar with the history, Einstein originally introduced this concept in 1917 as an addition to his equations of general relativity. At the time, he was trying to create a model for a static universe, one that neither expanded nor contracted. When astronomers later discovered the universe was indeed expanding, Einstein reportedly called the cosmological constant his greatest blunder. Fast forward to the 1990s, when astronomers made the shocking discovery that the universe wasn't just expanding, it was doing so at an accelerating rate. This unexpected cosmic acceleration led scientists to revive the idea of a cosmological constant, but now as an explanation for the mysterious dark energy driving this acceleration. For years, the simplest explanation has been that dark energy maintains a constant value throughout space and time. But DESI's first-year observations hint at something potentially revolutionary, dark energy that changes over time. Andrew Heron, a physicist at Argonne National Laboratory and DESI member, puts it in perspective. If the DESI result holds up, it means that a cosmological constant is not the origin of cosmic acceleration. It's much more exciting. It would mean that space is pervaded by a dynamically evolving fluid with negative gravity, which has never been observed in any tabletop experiment on Earth. To help investigate these potentially groundbreaking observations, researchers at Argonne have turned to Aurora, one of the world's most powerful exascale supercomputers. They're running enormous simulations that model how the universe evolves under different dark energy scenarios. The team created two massive simulations, one assuming constant dark energy as Einstein's theory suggests, and another where it changes over time. Starting with identical initial conditions, they can track even the smallest differences that emerge as these virtual universes evolve. These simulations would have taken weeks of compute time on our earlier supercomputers, but each simulation took just 2 days on Aurora, explained computational scientist Adrian Pope. This dramatic speedup allows researchers to respond much faster to new cosmological observations. Gillian Beltz-Morman, a postdoctoral research fellow at Argonne, emphasized the value of these simulations. Since we can't create a mini-universe to conduct experiments, we can test theories by using really big computers like Aurora to simulate the growth of structure in the universe over time. While these simulations can't directly confirm DESI's findings, they provide a crucial testing ground for examining different measurement techniques and determining whether the patterns observed by DESI represent genuine new physics or are artifacts of how we collect and analyze data. To maximize the impact of this work, the Argonne team has made all their simulation data publicly available, allowing the broader scientific community to explore different analysis methods and help determine whether Einstein's cosmological constant truly needs to be replaced with a more dynamic model of dark energy. If confirmed, this finding would represent one of the most significant shifts in our understanding of the universe in decades, potentially opening doorways to entirely new physics beyond our current standard model of cosmology. That wraps up today's episode of Astronomy Daily. What an incredible journey through our cosmic neighborhood we've had. From a Soviet probe completing its 50-year orbit of Earth, to China's ambitious plans to sample Venus's toxic atmosphere, the hunt for rogue planets wandering our galaxy, an ingenious satellite rescue mission, and potentially revolutionary discoveries about the very nature of dark energy. I'm your host, Anna, and I want to thank you for joining me as we explored these fascinating developments in space science and astronomy. The universe continues to surprise us, challenging our understanding and pushing the boundaries of what we know. And before I go, a quick reminder to visit our website at astronomydaily.io, where you can sign up for our free daily newsletter and listen to all our back episodes. We're constantly updating with the latest astronomical discoveries and space exploration news that you won't want to miss. Don't forget to subscribe to the podcast on Apple Podcasts, Spotify, YouTube, or wherever you get your podcasts to stay connected to the cosmic frontier. Until next time, keep looking up.